Hi everyone, we're with our TAs for Geology 120, Joe and Jenna Reimer, and we're gonna have a little conversation so you guys can get to know them. So, first question, Joe, where are you from?
I'm from upstate New York, probably like 40 or 50 miles north of New York City. Went to college in Lancaster, Pennsylvania, and grad school in Shippensburg, Pennsylvania, and I'm a doctoral candidate here at University of Maryland.
Thanks, Joe. And you, Jenna, where are you from?
So I grew up in the Philadelphia suburbs, and my senior year of high school, my family moved to Ocean City, Maryland. So my family has been living there since 2015, and now I just kind of live here.
Okay. And what's your favorite scientific discovery, Joe?
I think insulin, because that was kind of like originally wasn't for any like financial gain. The person that invented it never patented it, and just like cured a bunch of people that were like had type 1 diabetes. So I thought that was like the most altruistic recent discovery.
Yeah, good choice, Joe. And Joe has a very good heart. You guys are gonna learn that in this class. Not that Jenna has a heart made of black heart, but Jenna, what's your favorite discovery?
I think my favorite scientific discovery is the discovery of the double helix structure of DNA. I have a little bit of a biology background, and it was just kind of interesting how that discovery just kind of unlocked a lot of new fields, such as like genomics, and just kind of have led to a lot of different biological discoveries over time.
Oh, great. Okay. So, what research do you do?
So I research urban streams here in Maryland and also in DC. I sample them pretty regularly and compare data that I get from our lab to data provided by the United States Geological Survey. And I try to use specific conductance, which is a measure of salinity, as a proxy for things like metal loads and nutrients, and hoping to expand that in the future.
Oh, great. Thanks, Joe. And how'd you get into that?
I got into that. I had been doing research on mill dams and how they affect nutrient loads in the Chesapeake Bay for the past almost decade. So I wanted to do research closer to the Chesapeake Bay and found our lab here and have loved it ever since. It's like a little bit different than my previous work, but it's trying to figure out and fix the same problems.
Yeah, that's great, Joe. And Jenna, what research do you do?
So I'm actually the lab manager for Dr. Kaushal, aka Sujay's biogeochemistry laboratory. And so I've been doing research with some on-campus streams, most notably Campus Creek. And Campus Creek underwent a stream restoration, and they used a regenerative stormwater conveyance system, which is basically a series of step pools that let the water filter through. It decreases the speed of the water, so it doesn't erode the banks as much, and I'm sure we'll get into this a little bit more in class. So I kind of look at the water quality of the RSC pools and just kind of monitor the long-term data of the campus streams.
Yeah, and how'd you get into that?
So, as I said before, I have a background in biology. I was a biology major here at the University of Maryland for a few years before I changed my major to geology. In that time, I've had obviously research experience in biology and microbiology. I've done research with the entomology department. I've done research in metamorphic petrology through the geology department. But through the geology department, I took a lot of hydrology classes and also took a class taught by Sujay. And after graduation, Sujay offered me a job in his lab. And so I've been doing a lot of hydrologic research ever since.
Yeah, so both of you have quite an extensive knowledge in the geosciences and really are really well-rounded scientists. Um, so we're very lucky to have you in this class, and I really mean that sincerely. And so we've been talking in class about the scientific method, and Joe and Jenna use the scientific method in their research and what they do all the time. Scientific method involves asking a question, coming up with a testable hypothesis, and then collecting data to test that hypothesis and analyzing it, and then coming up with some kind of interpretation or conclusion. And then they often take it a step further and then basically figure out what that means in terms of managing water resources, or whether it's road salt or restoration here on campus and beyond. So Joe, can I start with you and ask how you employ the scientific method with your research, and what's your favorite part of the scientific method?
I employ the scientific method in my research by kind of like doing background research and reading a lot of articles that Sujay and others have published to kind of form a basis for my research. And there were one or two articles that mentioned that metals had been released due to road salt. So I kind of latched onto that and formed my hypothesis that metals like manganese and strontium and iron might be released due to these salting events. And my favorite part is checking that hypothesis, because that's kind of where you see where your research was right and where you might make new discoveries. And we found that of those metals, copper, strontium, and manganese were mobilized by salt, but not iron. So even if your hypothesis is found out to be partially wrong, that doesn't mean that your time was wasted. You can make different inferences and discoveries from that.
Yeah, and that's Joe's pointed out a very important part of science, where there's serendipity, where you make discoveries where sometimes you think you won't. But Joe's outlined that he looks at previous literature to come up with a testable hypothesis, and then his favorite part is looking at the data and analyzing the results, and then he takes those results and then translates them into management actions and recommendations. Jenna, what about you? How do you use the scientific method, and what's your favorite part of the process?
Yeah, so I guess in terms of the research I do, we start by asking the question, and in terms of the Campus Creek RSC, we visually saw that they were putting in the step pools, so then that prompted us to ask what is the effect of the step pools on the stream chemistry, and how is that going to affect our long-term monitoring. So then we sat down, did some research, looked up papers through the library database, and kind of educated ourselves on the RSCs and previous research that had been done. Then we formed our hypothesis of how the RSC was going to affect the stream. So we hypothesized that it was going to increase a lot of ions and different elements in the stream. So then we started testing that hypothesis by collecting data. So during the summer, we would sample the Campus Creek stream twice a week, and we just take little grab samples. We also test for temperature, pH, and conductivity. We collect all that data, then we sit down and analyze it. So we'll graph it. We analyze our samples for different elements and different ions. And then after we have it all graphed, we sit down again and kind of look at it and ask, what does this data mean? So we analyze it, and again, we form conclusions about what had happened in the stream, and we end up taking those conclusions and we write papers, we publish the data, we present at conferences. So I guess our work doesn't really exactly stop at just making the conclusion. We kind of do a little more outreach and spread our findings a little more. So I think one of my favorite steps is the research, because I like kind of seeing what other people have done with the research. I like building my general knowledge base. I like reading things and then applying my past research experience to them and kind of formulating a plan on our next steps in data collection.
Yeah, that's great. So, I mean, Jenna's project hits home here on the University of Maryland campus where they restored a stream to see if it could improve water quality. She's testing to see if that really works or not, or if it leads to any kind of unintended consequences. And so Jenna's, going out in the field, visually looking at the stream to see what kinds of things are going on, and then looking in the literature, she came up with testable hypotheses. And then Jenna just walked you through the whole process of analyzing data, and then also talking about how the results are disseminated in the scientific community. And Jenna is a master at coming up with plans and executing those plans, so it's no surprise she's very organized. And I see Joe's kind of got a half smile, but he knows that too. He also is a man with a plan. So it's no surprise about Jenna liking to coming up with the executable plan to make it all happen and stuff. So, last question, and thanks for standing out here. We know that it's cold, and Jenna and Joe thought it was important that you guys would be able to actually see their faces. They actually are housemates together, so.
And they were roommates.
And roommates, so they're not they're not breaking anything. So.
We have our masks.
Yeah. So.
Also, the feels like temperature is 20 degrees right now, so we're shivering.
Yeah. But they thought it would be good to put a personal touch to it. So thanks guys. Last question is, what do you plan to do? What's your after employing the scientific method and your training, and you guys are talented and we're lucky to have you. What do you plan to do in the future?
I hope to finish up my PhD here, maybe move on to a postdoc, and then hopefully gain my own professorship and start my own research on similar things to the road salting and the environmental effects of human activities in the future.
Yeah, that'd be great. You're well on your way with that, and we wish you luck, although you don't need it. Jenna, what about you?
I have, I guess, similar life goals as Joe. I'm actually currently applying to graduate PhD programs in places that are a lot warmer than College Park. And so, like Joe, I hope to graduate with my PhD and take some postdoc positions and then be a faculty research professor at a university somewhere. Hopefully that's also warm.
So yeah, any graduate program would be very lucky to have you, Jenna, and we definitely we're definitely lucky to have you in our lab as well. And I think you and Joe will be a great resource to students with all your knowledge and going through the process yourselves. And we all look forward to meeting you on Wednesday. And so with that, I'll let Jenna and Joe get inside. Thanks.